Alright, action potentials and local graded potentials. To understand this, you need to know the cell. And so the cell has the NAK pump. Alright, and it has K leak channels. I'll just put there like a little bit. And there's also a little bit of NA leak channels, right? But then there's also going to be K voltage gated K channels, and they have around the same amount here of voltage. So I'll put 4 and 4. So 4 and 4. So there's 4 voltage gated. So if you voltage gated, and then you have the lines, which is leaks. So typically in the cell, right, in the NAK pump, you're gonna put out 3 NAs, and then you're gonna lose, and then you're gonna gain 2 Ks. So NA is coming out, and K is coming in. And then for the leaks, for the leak channels, right down here, leak channels, they will always be leaking something. So they will always be leaking Ks and NAs. And then the voltage gated, they are gated by voltage, and so you need to power them for them to be open. And this is when we start to get to the action potentials part. So basically, when other neurons talk to each other, neurons have dendrites. And so over here, they're the dendrites. The dendrites will take in information from other neurons, and they will have to get to a certain threshold over here to create a reaction. For example, these dendrites can receive different signals, right? And this will be, say this is a -5 signal, right? +2 signal maybe. This is a +5 signal maybe. And this is a -5 signal, okay? And so these are called the local potentials or the graded potentials. And so these can add up. And so eventually they'll add up to be above the threshold here. So the threshold, so the resting potential is going to be -70. So this is where you're at normally at rest. And you have to get to -55-ish to reach a threshold. So say eventually all these dendrites will add up and will be +15, right? And +15. And so you'll reach the threshold right here. This is when the action potential happens. So anything above this line is the action potential. Anything in the green right here that I just highlighted is the action potential. Everything right here is the graded. Hold on, let me erase that real quick. If I can, yeah. So what I'm going to put in red is the graded potentials. So over here is the graded potentials, or local potentials. So this is the point when you're adding, but then this is all of it is the excuse me, action potentials. So what happens here is, let's do it in a different color. So we have from here to here, the pink, the voltage gated NAs are now open because there's enough voltage to open the NAs. So right here, NA open. And so that means a ton of positive ions are coming in, And so that will increase the charge to make it a positive number. This is around like positive 30. And so it'll increase the charge because positive ions are coming in, and so it'll increase up to positive 30. Around here at the peak, now I'll put it in purple, you have the voltage gated K channels are open. And because they open so slow, they're going to be opening like around the peak here. The NAs open pretty fast, so they're going to be the ones acting first, and then the K channels will be opening later. So then once the K channels open, they're releasing all the Ks. They're releasing all the Ks. That's why you see the charge is going to negative. So the K plus ions, positive ions, you're losing positive ions, which means you're being more negative. So it's going all the way down to here, and this is the point where you're under the resting potential, and now you have to get back to the normal, the resting potential, which will just be from homeostasis, or from the NAK pump. So this is the action potential. So over here we have the depolarization. We have depolarization in orange. So anything here is depolarization. Where you're increasing the charge on something, increasing the charge on the cell. And here you have repolarization. And then down here where you're under the resting, so like over here kind of, you have hyperpolarization. And obviously like around here would be the resting membrane potential. Boom. Action and local potentials.